And we are back once again with Flip Geometry. I am Mr. Llanos, and we're going to get right into lesson 1-4, angle measure. After this lesson, you'll be able to measure and identify angles, and you will also be able to identify and use congruent angles and the bisector of an angle. Now, before we talk about angles, we need to talk about a ray. A ray is a part of a line. I'm going to go ahead and draw a line here. I'm going to put a point, place a point there, and call it B. A ray has one endpoint and extends indefinitely in one direction. So if I were to follow this ray, it would start here, I'm going to use a different color, and then go in one direction. But it does have an endpoint. So I'm going to highlight the part that I'm talking about. It starts at one endpoint and goes on indefinitely in one direction. Here we have another ray, and I'm going to show you now how to name this ray. If we were just speaking about the part of the line here that starts at N and goes on through Y indefinitely, the way I'm going to name this ray, since N is the endpoint, I'm going to say NY. I'm going to draw a line over it, and because it's starting at N and passing through Y and it keeps going, I'm going to put the arrow on this side. Now, if you remember back to lines and line segments, it didn't really matter in which order the letters appeared, but for ray it does matter. You need to start with N, which is the end point, and Y is the second letter. So you cannot write it YN. You cannot do it that way. Here we have a line with 3 points on it, KLT. If we were to talk about ray LT, that would be the ray that starts at L and continues on through T. That's LT. If we were to talk about ray LK, that would be the ray that starts at L and goes through K. If you choose a point on a line, that point determines exactly two rays called opposite rays. Since both rays share a common endpoint, opposite rays are collinear. So if we're looking at this example here, this figure, line L here, it's got 3 points, H, J, and K. It's got two rays, one ray named JK and the other one JH. One ray starts at J, goes one direction, and the other one starts at J and goes in complete opposite direction. But they are collinear and they are named opposite rays. An angle is formed by two non-collinear rays that have a common endpoint. So if I were to draw a ray starting from point J, and I'm going to name another point here, we'll call it V, and then have another ray that's non-collinear to JV in another direction, call this one T. Here we have two rays. We've got ray JV and ray JT. Because they share a common endpoint, J, these two rays form an angle. Now an angle is made up of a few different parts. The rays are called the sides of an angle. So this ray JV and this ray JT are the sides of the angle. And then the common endpoint that they have is called the vertex of the angle. So we could say that ray JV and ray JT are the sides of the angle, and point J, the common endpoint, is the vertex of this angle. So here we have an angle with vertex P, and we have ray PK and PW. Now, how do we name an angle? We're going to start by writing our notation for an angle, which is just a little angle sign, and then we can take our letters and write them out: K, P, W. Notice that the vertex has to be in the middle. Again, you can also write it the other way. It doesn't matter which order you write it in, W, P, K. But again, you must notice that the vertex is in the middle. There are a few more ways you can name this angle. I can also just use that very vertex and call this angle P. And lastly, sometimes you will have a number inside of the angle, and you can use that number to also name it. So angle 1 could be the name of this angle. These are all acceptable ways for naming this particular angle. One thing you need to remember about naming an angle is that you may not always be able to use just one letter to name that angle. For instance, if I were to ask you to find angle P, there are actually 3 possibilities for angle P. We can have S, P, J, or J, P, K, and then lastly we can have S, P, K. All 3 of those angles share the same vertex, vertex P. So I'd be able to write S, P, K, or angle S, P, J, and lastly J, P, K. An angle divides a plane into 3 distinct parts. Points Q, M, and N lie on the line. Points S and R lie in the interior of the angle. And lastly, points P and O lie on the exterior of the angle. Let's name all the angles that have B as a vertex. I see 4 distinct angles, and I'm going to name them all for you now. We've got angle A, B, G. We've got angle D, B, A. We've also got angle E, B, D. And lastly, angle G, B, E. Now some of these we can use numbers to name them, like DBA can be named angle 7. DBE, which is the same thing as EBD, can also be named angle 6. And then the last one here, GBE, can be named angle 5. So these are just different ways to name the same angle. But we've got 4 distinct angles that have B as a vertex. Let's name the sides of angle number 5, which is that one there. So we know that our sides, we're just going to highlight them. And we can start by naming our sides. Remember, they're going to be rays. So I'm going to start off with our vertex BG. And then our second ray is going to be BE. That second ray can be also named BF, only because it starts at B and it passes through both of those points. So you can name it either or, BE or BF. Write another name for angle 6. Again, if we notice, angle 6 is right here, and if we trace this angle, our vertex is going to be B, and we can name it angle DBE or angle DBF, only because again it passes through both of those points, so it does not matter which of the 2 you choose. Let's take a look at this figure, this map that we have here, and name all the angles that have B as a vertex. Well, we can start by naming angle ABD. Another way to name that angle would be angle 1. Also, we have angle DBC. Another way to name that angle is angle 2. Now let's name the sides of angle 5. I'm going to trace angle 5 with this highlighter so you can see which is the angle that we're speaking of. The first side that we want to talk about is ray CG. Again, we write our rays CG. Another way to write that same ray is CJ. That would be one way to name this ray right there. Okay, the other ray, and I'm going to trace that one out, is this guy right here, and that would be ray CA. It's the correct notation for that. And also another way would be CB. So we could use either CG or CJ because that's the same ray, and then CB and CA, which is the other side of angle number 5. The next question asks us, what is another name for angle GHL? I'm going to highlight angle GHL so we can see the angle more clearly, and we can name that same angle. Well, first of all, we can name it with that number, angle 7. We can also name it LHG, just backwards, LHG. The vertex H needs to be in the middle. And because this is the only angle that vertex H is referring to, we can also just name it angle H. Finally, we need to name a point in the interior of angle DBK. Again, I'm going to highlight DBK so you can see the angle, and we need to name a point that's on the interior of DBK, and the only one that we see here is this one. I'm going to use a different color so you can see it. Point E. Angles are measured in units called degrees. The degree results from dividing the distance around a circle into 360 parts. We are all aware and remember that a complete circle measures 360 degrees. When measuring an angle with a protractor, there are a few things you need to remember. 1. The protractor has two scales running from 0 to 180 degrees in opposite directions. So if you notice, there's a 0 here, and it goes up to 180 degrees on the outside, and then on the inside there's also a 0, and then this also runs to 180 degrees. Next, you want to remember to place your vertex on the center point of your protractor. Third, you want to align one of your sides, so one of your rays, to the 0 on either side of your protractor. So if you see ED is aligned with the 0 on the right side of the protractor. And lastly, since ED is aligned with that 0, you want to use the inner scale, the number on the insides, to count the number of degrees. Side EF intersects with 50. You can't really see it because I just covered it up, but it intersects with 50 degrees, not 130 degrees. Because it starts here, you want to count these numbers there to 50 degrees. So the measure of angle DEF equals 50 degrees. You can classify an angle by its angle measure. The three classifications are right angle, acute angle, and obtuse angle. A right angle just means that the measure of that angle equals exactly 90 degrees. The notation for a right angle that you can see here in the corner is just a little box where the vertex is, and that just means that equals 90 degrees. Now, an acute angle, the measure of an acute angle, is greater than 0 but less than 90 degrees. So anywhere in between 0 and 90. It cannot equal 0 or 90 degrees. That would be an acute angle. An obtuse angle is an angle, as you can see, that is greater than 90 degrees but less than 180 degrees. So again, you see here's the right angle. An obtuse angle is going to be greater than 90 degrees. Let's measure angle WYT and then classify it as right, acute, or obtuse. Let's highlight it first to see which angle it is that we're talking about. WYT. That's the angle that we want to measure. So we're going to go ahead and place a protractor above that angle, and we lined up our 0. First of all, we placed our vertex, which is Y, at the center point, and lined up one of our sides, YW, with 0. So now we're going to measure from this 0 to T, if you can follow along that arrow there, okay? And we're going to use the numbers on the inside and follow along that it measures 130 degrees. So the measure of angle WYT is equal to 130 degrees. And because it measures 130 degrees, we would be able to classify this angle as being an obtuse angle. Now let's measure angle TYU and classify it as right, acute, or obtuse. Angle TYU is this angle here, TYU, and then we're going to use our protractor to measure it. Since it goes through this 0, we're going to count the outside numbers, and TYU is going to be the measure of angle TYU is going to equal 45 degrees. And because it is 45 degrees, that would make it an acute angle. Just as segments that have the same measure are congruent segments, angles that have the same measure are congruent angles. You notice the notation that we use for showing congruent angles are just little arcs that we have inside of the angle. So again, if you've got 2 arcs, it would be congruent to the other angle that has 2 arcs, and we would write it out just like we would congruent segments. So in this case, it'd be angle FED is congruent to angle CBE. We notice there's another set of angles that is congruent to each other, this angle here and that angle there, so we would write that one out as well. Congruent statement would be angle ABC is congruent to angle DEF. Another way to show congruent angles is by the notation you see here. So we can easily say that angle J is congruent to angle M because they have the notation. Sometimes it's just a ticky mark inside of the angle. So if it has 1, it'd be congruent to the same one, or to another one that has 1. And if it has 2, it would be congruent to another one that has 2 as well. Now let's use this idea of congruent angles to solve a problem. So it says wall stickers of standard shapes are often used to provide a stimulating environment for a young child's room. A 5-pointed star sticker is shown with vertices labeled. Find the measure of angle GBH and the measure of HCI if angle GBH is congruent to angle HCI, and the measure of angle GBH is 2x plus 5, and the measure of HCI is 3x minus 10. So we could easily set up an equation because we know that the angle GBH is congruent to angle HCI. Okay, so we know GBH is 2x plus 5, and HCI is 3x minus 10, and now all we have to do is solve for x. Let's go and subtract 2x from both sides. Leaves us with 5 equals x minus 10. Add 10 to both sides, and x equals 15. But they want to know what the measure of angle GBH is equal to. So we're going to plug that back into the equation for GBH, which again is the angle of GBH is 2x plus 5. Plug 15 back into that. 2 times 15 is 30 plus 5, and it is 35 degrees. Also, we need to find the measure of HCI, but since we know that they are congruent, that means the angle measures are equal to each other, so the measure of angle HCI is also 35 degrees. A ray that divides an angle into two congruent angles is called an angle bisector. If ray YW is the angle bisector of angle XYZ, then point W lies on the interior of angle XYZ. And because it is the angle bisector, you can see now that it cuts angle XYZ directly in half, creating two smaller angles. So XYW, angle XYW, would now be congruent to angle YWZ. In this final figure for this lesson, we've got ray KJ and KM that are opposite rays, and ray KN bisects JKL, angle JKL. So before we go on any further, since KN bisects angle JKL, we can now say that these two angles are congruent to each other. Now, if measure of angle JKN is 8x minus 13, and the measure of angle NKL is 6x plus 11, find the measure of JKN. So we can start off by writing a congruent statement. Angle JKN is congruent to angle NKL. And since we know what each of them are equal to, we can just write an equation out. 8x minus 13 is now equal to 6x plus 11. Let's go ahead and subtract 6x from both sides. We're left with 2x minus 13 equals 11. Add 13 to both sides. We're left with 2x equals 24. Divide by 2 on both sides, and x equals 12. And since we need the measure of JKN, we know that equals 8x. Well, we can plug the x in. 12 minus 13. 8 times 12 is going to be 96 minus 13. And we know that that angle equals 83 degrees. We are finally at the end of lesson 1-4. I know there was a lot in there about angles and their measures and what makes up an angle, but I want you to take a few moments and try those problems before going on to the next video.